4.5, fractions to decimals in order of operations. This fractions to decimal thing may seem kind of insignificant right now. However, in the next unit where we go over percents, this is going to become, well, hopefully it may become more prevalent, okay? Now, one of the problems we run into is a number like this one, right? It says, write the following number as a decimal. Well, we don't look at whole values like this as decimals, and it wouldn't matter if this is negative, by the way. But we see this is 10, and it's like, well, there is no decimals. And the truth is that there is. And sometimes there's a need for it, and we kind of found this in, I think it was that last problem in that last section, where we need other or decimal values from a whole value like this one. And the truth is that it does have a decimal right there to the right of the ones position, which is where the decimal always goes. But what are the values of the decimals? Well, the tenths would be 0, the hundredths would be 0, and you just get a bunch of zeros after this, okay? Now, we saw the importance of this with using long division in that problem that we used the zeros, right? As this one where we need to know that there are decimal place values if we need them using long division. So writing fractions and mixed numbers as decimals. If it's a mixed number, you just keep the whole number as is. And the sign of it, by the way. So if it's negative, you just keep it negative. The only thing we're really dividing is the fractional part of the mixed number. If there is no whole value, it's just a proper fraction, I suppose. Even if it was an improper fraction, you're still looking at division, though, okay? Use long division and then keep the decimal in its place. And then, like we showed with the 10.0, you show some phantom zeros in the place values of the decimals when it's necessary or needed. And again, that makes the number bigger or big enough to work with. So a problem like this one, let's demonstrate this again, all right? This is really going to show is 4 divided by 5. Now this one says round to the nearest thousandth if it's necessary. But as long division, this would show as 4 divided by 5. Well, 5, it won't go into 4, right? And this is where we need those decimal place values, particularly with the 4, to make it, instead of 4, now we'll be looking at it as 40. So we keep the decimal where it is. We can extend that long division line. Well, now 5 goes into 40 how many times? 8 times, right? Well, 8 times 5 is 40. When we subtract, we get 0 remaining. And you could say, well, I'm going to drop another 0. And I just like dropping a bunch of zeros. And, well, it just goes into 0 times, okay? And again, like I've said before, math people are kind of lazy, so we don't really show those zeros because there's an infinite number of them, which we'll get into here in a second. But this would be my answer for this. And again, we can confirm it by typing the fraction into the calculator, 4 over 5. Enter gives me 4 over 5. Just push that arrow button above the enter button, and it shows me 0.8. For the Casio users, you're looking at that SD button, which we've talked about today, right? Something like this. Well, what do we do about a number like this one? Now, it does say to round to the nearest thousandth. And, yeah, this is 1 divided by 6. We'll show the division part of that, which means that it's 1 divided by 6. Now, I've talked about this before, but not the 0 thing, which we need. Right, 6 won't go into 1, so that's 0. So I'm going to move the decimal up there. Now I look at this as 10. 6 goes into 10 once. 1 times 6 is 6, and I subtract, I get 4. 6 doesn't go into 4, but if I make it 40 by dropping another phantom 0, that'd be nice. 6 goes into 40 6 times. 6 times 6 is 36. Now we've seen this pattern before. I got a 4 there, and so I got to drop another 0. Now let's say that we didn't notice a pattern. We said, well, how many times is 6 going to 40? It's 6 times. 6 times 6 is 36. I subtract, I get 4. Hopefully by now you've noticed the pattern, particularly of these 4s, right? We got 4 right here, and a 4 right there, and a 4 right there. It's showing that the 4 is coming back over and over, which also means that eventually this is just going to be a bunch of 6s rolling out from here, right? Now, there is a way to show that, and we're not too concerned about it with this notation in Math 950. I'm still going to show you guys, though, so you know about it. This one said round to the nearest thousandth. Well, right now, I got tenths, hundredths, thousandths. That's the 6 right here. So I look to the right. This 6 is 5 or more, so I need to take the 6 in the thousandths and add 1, which makes this rounded 0.167. And that'd be my answer for this one. Again, well, I'll just put it in the calculator to check. 1 fraction button 6, enter, arrow, bam. It shows me that that 6 was repeating. So if I rounded it, I should get the 0.167. The way to get the calculator to show 0.167 is to force it to only have 3 decimal places. Now this is how you're going to do it. Specifically with this TI-30 is you're going to go to mode. Just click on mode there in the top left-ish.
Okay.
And then I'm going to go down to where it says float. Now float means the calculator is telling you I'm just going to show you as many decimal places as I feel I can or as is necessary for a problem. Now if I wanted, because this is thousandths, that's 3 decimal places. So I'm going to say, look, I need you to show me 3 decimal places. So I'm just going to go over to 3. I click enter, and then second mode, which is quit. Now if I type in enter, it will round it to the 3rd decimal place for me. So that's how you would force the calculator to start rounding to that specific decimal place for you. If you keep it like this, right? Like I've told the calculator in the mode, I want 3 decimal places, but I'm saying that to the calculator all the time. So if I don't want that anymore, then I need to go back into mode and then change it back to either float or whatever decimal places I want it to round to. So that last example brings up what we call bar notation. And again, I don't think we see it too much in 950 because it's going to tell us more to rounded values. In 980, it may become, if I remember right, it becomes more important in 1010 as well. But when we see a number repeat like we did in that last one, where we saw 0.16 and then a bunch of 6s, right? And it would have gone on forever. Now the calculator rounded it to 7. Not that it would be the actual value. It just rounded it for us. Well, once we see that in a pattern of dividing, that a decimal repeats like this, it's going to go on forever. Now, like I said, math people were pretty lazy. So he said, look, I don't want to show a bunch of 6s on this. I know that the pattern repeats, and I want to show that it repeats without having to write a bunch of 6s on this. Well, they created this bar notation where if we put a bar above the number or numbers that do repeat, then we get to assume that it does repeat. And that's why it's called bar notation. It's just a bar, okay? So this, what I've written here with 0.16 bar, is the same as getting that answer that we had with 0.16, and then the 6's repeat forever and ever, okay? So again, if it tells us to round, don't worry about using bar notation. If by chance it tells us to use bar notation, then use it. It should be in the math quill where if you click on the box of the homework, it should just come up as an option for you. If it doesn't, then we should know we need to round. So write this mixed number as a decimal, round to the nearest thousandth if necessary. So we do not need bar notation in this case. Now this is a mixed number, and it's negative 4 1/3. Now this means that it's negative 4 point something. We just got to figure out the decimal part of it, which is the fraction. Well, this is 1/3, which would show as 1 divided by 3. which is long division, is 1 divided by 3. So again, 3 won't go into 1. So I've got to make this a 10. Just again, we're making the decimals in the same place values, just lined up. 3 will go into 10 3 times. 3 times 3 is 9. And when I subtract, I get 1. Now this is enough to know that this is going to repeat because I started with 1. And now I've got a 1 after, I guess, 1 division of these place values. Now we can confirm this by saying, well, I can tack on another 0 to make that 10. 3 goes into 10 3 times, which is 9. And again, we see this 1 repeat. So it's just going to be a bunch of 3s after that. Now this one said to round to the nearest thousandth, which is this 3 right here. And if I look to the right, this is less than 5. There's 3, or it's 4 less. I forget the rhyme. So the 3 in the place value is just going to stay the 3, which means it's negative 4.333. And that would be our final answer right there. But, you know, again, we can check by typing this in as a mixed number like this, negative 4 1/3. So it gives me the improper fraction first. If I push the arrow button, it will change it to a decimal for me. So that confirms what we already knew, that negative 4 1/3 is negative 4.333 as a decimal rounded to the nearest thousandth. All right, order of operations, we'll show some work on this, okay? Now, I'm not going to do all the work by hand other than the operations. And we kind of expect you guys to be able to do that, the operations by hand, if it were necessary. On the other hand, though, we are able to use calculators at this point in the class. So I recommend using calculators to simplify your work, right? So order of operations, I would be looking only at the parentheses first. Now, again, I said I'm not going to be doing this by hand. I'm just going to type this part into the calculator. 49.89 minus 45.69. And that ends up being 4.2. So that simplifies that part of this expression for us. Let's write it out as we see it. All right, so that definitely simplified this problem for us. Now let's go to the exponent on this one, the power of 2. So I got 4.2 to the power of 2, which in my calculator is, let's see, 4.2 to the power of 2, 17.64. So that's 17.64. Let's write out the rest of this. Times that 17.64. All right, yeah. Oh, I divided, didn't I? Oh my gosh. So I do need that negative 109.86. So yeah, again, just going back to this, and again, it's okay to make mistakes like this. I don't know, it's just a brain fart, you guys, where I just typed it in as division. I think I read it as division. Maybe I was looking at this sign over here. It doesn't really matter. I did it incorrect, so we had to fix this. It's not multiplication. It's not division. It is multiplication, which changed the answer completely, and it is much nicer this way. The final thing on this one, and I should have mentioned this before, is I would actually go back and type this full expression into the calculator because I can, including the parentheses. So let's do that and just double check that this is negative 109.86. So yeah, after working this problem out with the calculator, we just typed in the full expression in the calculator and gave us the same answer. And that allows me then to circle this with confidence.